Chapter 9, Lesson 3, Biological Compounds. Right here on the left-hand side, you'll see what you'll learn. Our objectives for today's lesson. Students will describe how large organic molecules are made. Students will explain the roles of organic molecules in the body. And students will explain why eating a balanced diet is important for good health. Now, one reason why I always like to look at biological compounds in this lesson specifically right before Thanksgiving, because we often think about the big, huge Thanksgiving meal that we're going to have maybe with our extended family. Now, that might look a little different this year, but I still want us to understand what scientifically we're consuming when we're going through that digestive process and what it means to actually have a good diet that is important for good health. What is a polymer? Now that you know about some simple organic molecules, you can begin to learn more about complex molecules. One type of complex molecule is called a polymer. A polymer is a molecule made up of many small organic molecules linked together with covalent bonds to form a long chain. The small organic molecules that link together to form polymers are called monomers. Polymers can be produced by living organisms or can be made in a laboratory. Polymers produced by living organisms are called natural polymers. Polymers made in a laboratory are called synthetic polymers. What is a polymer and how does it resemble a chain? Well, the word poly, or the portion of the word poly, means multiple. Like a polygon is multiple sides to a shape. A polymer is multiple molecules that are linked together. They're small molecules that are linked together with covalent bonds to form a large chain. To picture what a polymer is, it's helpful to start with small synthetic polymers. You use such polymers every day. Plastics, synthetic fabrics, non-stick surfaces on cookware are polymers. The unsaturated hydrocarbon ethylene, C2H4, is a monomer of a common polymer used often in plastic bags. The monomers are bonded together in a chemical reaction called polymerization. As you see in figure 15, the double bond breaks into each ethene molecule. The two carbon atoms then form new bonds with carbon atoms in other ethylene molecules. This process is repeated many times and as a result in a much larger molecule called polyethylene. A polyethylene molecule can contain 10,000 ethylene units. So you have these smaller, simpler organic molecules of carbon and hydrogen, these two ethylenes. Those double bonds are broken so that these carbons actually need to form another bond, and then they're put together as a polyethylene. So poly means multiple ethylenes. The carbon atoms were joined double bond each of the electrons to share with another carbon atom in another molecule of ethylene. The process goes on until a long molecule is formed. It's called polymerization. Proteins are polymers. You've probably heard about proteins when you've been urged to eat healthy foods. A protein is a polymer that consists of a chain of individual amino acids linked together. Your body cannot function properly without them. Protein, in the form of enzymes, serve as catalysts and speed up chemical reactions in the cells. Some proteins make up the structural materials in ligaments, tendons, muscles, cartilage, hair, and fingernails. Hemoglobin, which carries oxygen through the blood, is a protein polymer, and all body cells contain proteins. The various functions in your body are performed by different proteins. Your body makes many of these proteins by assembling 20 amino acids in different ways. 9 of the amino acids that are needed to make protein cannot be produced by your body. These amino acids, which are called essential amino acids, must come from the food that you eat. That's why you need to eat a diet containing protein-rich foods like those in Table 3. If you look here, you've got different types of amino acids that join together to form different types of proteins. Okay? In figure 3, table 3 here, you've got the different types of foods that have a high protein content. Chicken breast, eggs, milk, peanut butter, kidneys, they've got a number of grams of protein that are good for your overall diet. The process by which your body converts amino acids to protein is shown in figure 16. In this reaction, the amino groups of the amino acid alanine forms a bond with carboxyl group of the amino acid glycine and a molecule of water is released. Each end of the new molecule can form similar bonds with amino acids. The process continues in this way until the amino acid chain or protein is complete. So here's where you have two amino acids in your body, and the bond that's broken between those is this OH and H to form H2O, and now those two amino acids are put together to form this protein molecule. Carbohydrates. The day before a race, athletes often eat large amounts of foods containing carbohydrates, like the ones shown in figure 17. These are foods that contain a lot of carbohydrates. A lot of different breads and grains have a lot of that carbohydrates that you're looking for, especially if you're going to be competing as an athlete. What's in pasta and other food like bread and fruit that gives body a lot of energy? Well, these foods contain sugars and starches, which are members of the family of organic compounds called carbohydrates. You can probably tell from the word, carbo is carbon and hydro is talking about hydrogen. A carbohydrate is an organic compound that contains only carbon, hydrogen, and oxygen, usually in a ratio of 2 hydrogen atoms to 1 oxygen atom. In the body, carbohydrates are broken down into simple sugars that the body can use for energy. The different types of carbohydrates are divided into groups: sugars, starches, and cellulose. Table 4 below gives some approximate carbohydrate content for some of the common foods that we eat. Apples, white rice, baked potato, wheat bread, milk all have a plentiful amount of carbohydrates. You'll notice that some people often think about when they're going on a diet to try and cut out carbohydrates because they don't want to have an excess amount of sugar, because when our body breaks these things down, it actually turns them into sugar to be used for fuel. But if people are eating these things and they're not active, they're not exercising, they're not burning a lot of calories, then the carbohydrates that are broken down into those simple sugars can be turned into fat. So people like to avoid carbs when they're going on a diet. It's not necessarily the best way to do it. You still have to have a balanced diet, but if you cut out carbs completely, then you're removing yourself from having that energy source from those different types of foods. Sugars. If you like chocolate chip cookies or ice cream, then you're familiar with sugars. They're the substances that make fresh fruits and candy sweet. Simple sugars are carbohydrates containing 5 or 6 or 7 carbon atoms arranged in a ring. The structure of glucose and fructose, two common simple sugars, are shown in figure 18. Here's fructose and here's glucose. You notice that fructose is a 5 carbon centric ring and glucose has 6, one of those being an oxygen molecule. The structure of glucose and fructose are shown right here. Glucose forms a 6 carbon ring. It is found in many natural sweet foods such as grapes and bananas. Fructose is a sweet substance found in ripe fruit and honey. It often is found in corn syrup and added to many foods as a sweetener. The sugar you probably have in your sugar bowl or use in baking a cake is sucrose. Sucrose, shown in figure 19, that's down here. Here's your sucrose molecule, much bigger. Is a combination of the two simple sugars, glucose and fructose. In the body, sucrose cannot move through cell membranes. It must be broken into glucose and fructose to enter cells. Inside the cells, these simple sugars are broken down further, releasing energy for cellular functions. Starches. Starches are large carbohydrates that exist naturally in grains such as rice, wheat, corn, potatoes, lima beans, and peas. Starches are polymers of glucose monomers in which hundreds or even thousands of glucose molecules are joined together. Because each sugar molecule releases energy, when it is broken down, starches are sources of large amounts of energy. Other glucose polymers. Two other important polymers that are made up of glucose molecules are cellulose and glycogen. Cellulose makes up the long, stiff fibers found in the walls of plant cells, like the strands that pull off the celery stalk in figure 20. It's a polymer that consists of long chains of glucose units linked together. Glycogen is a polymer that also contains chains of glucose units, but the chains are highly branched. Animals make a glycogen and store it mainly in their muscles and liver as a ready source of glucose. Although starch, cellulose, and glycogen are polymers of glucose, humans can't use cellulose as a source of energy. The human's digestive system can't convert cellulose into sugars. Grazing animals such as cows have special digestive systems that allow them to break down cellulose into sugars. If you've ever eaten a stalk of celery, it's actually said to be a negative calorie. Because our body can't break it down, it actually causes us to burn more energy, to burn more calories than it is that it actually releases in the digestive system. So when you're eating celery, it's actually not bad for you or good for you in a sense, because you can't actually get any nutritional value from it. It's a way in which you could fill yourself up and have that full feeling and not eat more foods, which is maybe beneficial because you're not consuming other calories, but it's not something that's going to have a whole lot of nutritional value because our body can't break down that cellulose into more simple sugars. How do the location and structure of glycogen and cellulose differ? Well, glycogen is a polymer that also contains chains of glucose units, and cellulose makes up a long, stiff fiber in the walls of plants. So cellulose is the structure inside of glycogen. Glycogen is the polymer that contains the chains of those glucose units. Lipids. A lipid is an organic compound that contains same elements as carbohydrates, carbon, hydrogen, and oxygen, but in different proportions. They are the reaction products of glycerol, which has 3 OH groups and 3 long chains. Carboxylic acids, as shown in figure 21. Here's figure 21. Here's what that lipid looks like. Lipids are in many of the foods that you eat, such as the ones in figure 22. Here's figure 22. These are the different types of foods that contain lots of lipids. So you have butter, different types of dressings, cheese, meat. Lipids are commonly called fats and oils, but they also are found in greases and waxes such as beeswax. Wax is a lipid, but it is harder than fat because of its chemical composition. Bees secrete wax from a gland in the abdomen to form beeswax, which is part of the honeycomb. Lipids store energy. Lipids store energy in their bonds just as carbohydrates do, but they are a more concentrated source of energy than carbohydrates. If you eat more food than your body needs to supply you with energy for usual activities, the excess energy from the food is stored by producing lipids. If you eat more food than your body can burn, it turns into lipids. Lipids code word is fats. If you eat too much, it turns into something that your body is going to use to store, which isn't necessarily the healthiest thing. How can energy be stored in a molecule? Well, the chemical reaction that produces lipid is endothermic. An endothermic reaction is one in which energy is absorbed. This means that energy is stored in the chemical bonds of lipids. When your body needs energy, the bonds are broken and energy is released. This process protects your body when you need extra energy or you might not be able to eat. If you regularly eat more food than you need, large amounts of lipids will be produced and stored as fat on your body. See, what our body doesn't know is that our next meal is a lot of times in the United States especially taken for granted. You and I a lot of times know where our next meal is coming from, or we know where the next bit of food is going to be, and we know when our meal is coming, so we're never worried about this whole thing of survival. Our body doesn't know that, and our body pretends like, well, what if we're lost in the desert tomorrow and we need to have all this extra fat stored up to help us survive for a longer period of time? So our body is doing something that it naturally should in terms of its survival by producing that fat. We have to recognize that if we know where our next meal is coming from, if we know what is going to be provided for us, that we don't need to overeat each time or don't need to have extra snacks or extra sugars or extra that's always available to us, because it's not necessarily healthy, because as it's produced and stored, it's going to be showing up as fat on our body. Saturated and unsaturated lipids. Here's what some of those lipid chains look like, and there's a difference between them being saturated and unsaturated. You already learned what saturated and unsaturated means when it comes to hydrocarbons. Let's now apply it to lipids. Not all lipids are the same. Recall the difference between saturated and unsaturated hydrocarbons. Unsaturated molecules have one or more double or triple bonds between carbon atoms. Lipid molecules also can be saturated or unsaturated. As you can see in figure 23, when a lipid is saturated, the acid chains are straight because all the bonds are single bonds. They are able to pack together closely. A compact arrangement of the molecules is typical of a solid, such as margarine or shortening. These solid lipids consist mainly of saturated fats. So here's an example. You got this stearic acid. These fats are solids that straight chain molecules can pack together tightly. Bacon or butter contain these saturated fats or stearic acid, and all animal fats are saturated fats. So they look, what just happened? There we go. They look like they're in this nice straight chain. When it's an unsaturated fat, it's because there's a double bond in here, it's now not going to be straight and has a different shape to it. Unsaturated fats tend to be oils because they bent chains can't get close together. Olive oil, canola oil, things that you might use for cooking are examples of that. Let's see, when a lipid is unsaturated, as in figure 23, which is looked at, the molecule bends where there is a double bond. This prevents the chain from packing close together. These lipids tend to be liquid oils, such as olive oil or corn oil. Doctors have observed that people who eat a diet high in saturated fats have an increased risk of developing cardiovascular problems such as heart disease. The effect of saturated fat seems to be increased blood cholesterol, which can also be involved in the formation of deposits on artery walls. Fortunately, many foods containing unsaturated fats are available. Making wise choices in the foods that we eat can help keep your body healthy. Cholesterol. Cholesterol is a complex fat, that is present in foods that come from animals such as meat, butter, eggs, and cheese. However, cholesterol is not a fat. Even if you don't eat foods containing cholesterol, your body makes it its own supply. Your body needs cholesterol for building cell membranes. Cholesterol is not found in plants. Oils derived from plants are free of cholesterol. However, the body can convert fats into these oils to cholesterol. Deposits of cholesterol called plaque can build up on the inside walls of arteries. This condition, known as atherosclerosis, is shown in figure 24. When arteries become clogged, the flow of blood is restricted, which results in high blood pressure. This in turn can lead to heart disease, and although the cause of plaque buildup on the inside walls of the arteries is unknown, limiting the amount of saturated fat and cholesterol might help to lower cholesterol levels in the blood and might help reduce the risk of heart problems. Heart disease is a major health concern in the United States. As a result, many people are on a low cholesterol diet. What types of food should people choose on a low cholesterol diet? That would be to not eat different types of complex lipids or to avoid the different types of fats such as saturated and unsaturated fats. That finishes our section on section 3. Well, let's take a look at our assignment, our reinforcement. Here we're learning about biological compounds. Our directions are to identify whether each statement describes a protein, carbohydrate, sugar, starch, or lipid. So there are 1, 2, 3, 4, 5 of these here, and there are 6 different types of describers or definitions that we need to match these two. I'll read through them and you can go ahead and do the matching. Number 1, in the body, these are broken down into simple sugars that the body can use for energy. Which section talked about simple sugars and lots of energy? I believe it was something that was right in here. Carbohydrates and sugars and starches would be a good idea to search for simple sugars in those areas. Number 2, these are more concentrated sources of energy than carbohydrates are. More concentrated sources of energy are probably going to be in the lipids because they're similar to carbohydrates and they have carbon, hydrogen, and oxygen, but in different proportions. Lipids store energy, so you might look for the answer to that there. Number 3, these substances are found in fresh fruit and sweet candy. That obviously is describing sugar. Number 4, amino acids bond with each other to form these polymers. How do amino acids get put together and what do they form when they're put together? Number 5, hundreds or thousands of sugar molecules may join together to form these compounds. Now these are super high energy items that you might eat. I believe those were talked about in this section, starches right here. Number 6, these polymers are found in butter, ice cream, and beeswax. Butter, ice cream, and beeswax. Where do we find these types of polymers? So you're looking at those specific examples. I believe we just read about beeswax in beeswax, the lipid section right here. Hope that helps with numbers 1 through 6. In the next section, the directions say to determine whether the italicized term makes each statement true or false. If the statement is true, write true. If the statement is false, write in the blank the term that makes the statement true. So the italicized term would be what would be changed. Number 7, individual amino acids link together to form carbohydrates. True or false, carbohydrates would be the word to change. 8, there are 20 amino acids that bond in different combinations to form the proteins in a human body. True or false? 20 is your word that you're looking to see if that is true or false. Number 9, people who eat a diet high in saturated fats have a higher rate of cardiovascular problems such as heart disease. Is that true or false? Is it saturated or unsaturated fats that they're talking about? 10, lipids contain sugars and starches which make them good pre-race choices for marathon runners. Remember, lipids, that word can be considered fats. Fats contain sugars and starches. That might be something we need to look into. That would be the word to change, that being false. Numbers 11 and 12, it says to answer the following questions on the lines provided. I'll read through those. 11, give an example of foods that contain 3 groups of biological compounds that are part of a balanced diet. Give examples of foods that contain the 3 groups of biological compounds that are part of a balanced diet. So give me examples of foods from each of these different categories. So what are some examples of proteins that you need to eat? What are some examples of carbohydrates that you need to eat? What are some examples of lipids that you need to eat to have a balanced diet? So all 3 of those. 1, 2, 3. So proteins, carbohydrates, and lipids. All 3 of those. Give me an example from those 3 different groups. Number 12, how do saturated lipids differ from unsaturated lipids? You can find the answer to that right here as it's depicted, because one of these is showing a saturated fat or saturated lipid, and one is showing an unsaturated lipid, and it describes the difference between them right here on page 268. Well, that's on this online version, might not be the same page as yours, but right here where it says saturated and unsaturated lipids. That should help you complete the rest of your reinforcement. If you need to, go back, rewatch the video, or pause where necessary. God's blessings.